Good morning, students. Switch gear and protection. We have to say in our last lecture what is the fault analysis. How can the react the different fault in the power system with respect to magnitude of the current and the angle of the voltage as well as currents. And now we have to see about the component of the protective system. So we here to see the which type of the component we have to require for the protection of the any system, whether maybe like the wall power system, transmission line, distribution system, maybe a motors, generator, otherwise all another equipment like a transformer or any other statics device. So we have to first what is the main component for a power system. Here you can see the one basic diagram of the protection of the any system. There is the arrow mark is the here is the load. So there is the transmission line. There is the protection system with the circuit breaker system. There is the current transformer units. There is the protection transformer unit. So here we can use the every movements, every different protections system protective equipment. Here we see the for what the first equipment we have to need for the protection. For the protection, we have to first equipment need to transducer like a CT or PT. Why we need to transducer CT or PT? First of all, we need the any system measurements. So we have to need the measurement for the current measurement. We have to use the CT like a current transformer, and for voltage measurement, we have to use the PT potential transformer for the voltage measurement. We have to see the what is the CT construction of CT and PT. How can they will be react for the every current in the your chapter number maybe 9th or 12th whatever chapter CT or PT we will to see in this lecture, or the what is the function of the CT and PT. For first of all, that the function of the current transformer and voltage transformer to reduce their magnitude, not any another quantity. They will be remain same frequency, they will remain same angle, but this is also reduce the magnitude in terms of the pounds. Like a magnitude maybe a CT is the magnitude, reduce the magnitude up to 1 ampere to or 5 ampere. For 1 ampere is used for the most of the protective system, and 5 ampere used for the metering purpose. Or for the PT value is the most commonly value is the 110 voltage, and the or another value is used for the 220 voltage. And the second equipment is the relay. First of all, we say what is the function of the relay. This the relay function is the detecting the fault. What are the detecting the fault? The CT and PT given the signal to relay, and the relay was to decide the what is the this is a fault or the not fault. This first of all, the function is the detect the fault. Second is the issue the trip signal. There will be issue by your own self to this trip signal. And third is the relay current volt rate. Rating is 1 ampere or 5 ampere. Most of the relay is available in 1 ampere for the protections. Rest of her another relay is 1%. They will be available in 5 ampere. Relay voltage rating, most of relay voltage rating is 110 voltage, or another this special purpose relay they will be 220 voltage. Third one is the circuit breaker. Circuit breaker is the use for the limit, break up the current in the high levels. You have to see in the what is a circuit breaker in the chapter of the circuit breaker. How can they will react and how can they will just separate the two contact from the power system. And the fourth one is the battery. They will be used for the analyze the coil of the circuit breaker. Battery is used for that. And it's a minimum battery life. Backup capacity is to 10 to 12 hours for the any substation as well as the power system for the protecting system. Here you can see the previous diagram. There is a basic tripping circuit. So you can see that there is the fault occur to here. There is the one red line here. So when the point is a point F, we can call this is a point F. Sorry for that. There's a point F. There's the red line is a point F. First of all, whenever the fault is occur, so what first point to when the point is occur, increase the equipment current. Now we have to see the basic tripping circuit and how to basic tripping procedures for the any protective system. Here you can see the diagram we have to seen in the previous slides. There is the one red line is the faulty system or fault occur at this point. So when the fault occur in the this F, we have to denote this point as the F. So increase in the equipment current. If you this point have the fault is occur, so equipment current is increase, so equipment current is reflected to the city, and the city current is also be increased. So primary current of city is increased. So secondary current of city also be increased, and this current is increased. So current in the relay is also be increased. Current passing through for this coil is also being actual relay plunger will be a this type. If the current is increased, the system voltage may be a down or remain the some point of within the their range. So if this current will be increased, so the solenoid will be working here, and the solenoid will be working here. This plunger is down this side. If you plunger is down, then this all circuit is at the close. If you are this circuit are closed, the battery is already charged through some voltage, maybe as a 12 voltage or 112 voltage. Sorry, 110 voltage. Then the battery is the current is through the whole path, the current is passing through this path, and the current is passing through this path. So here the one magnetizing effect are there, the magnetizing effect are there, this plunger is attracted by these directions. If you this plunger is attracted by this direction, they will be the open circuits. If your circuit is sorry, coil is energized by the current of the battery's currents. So this current is flow through this coils, and the coil is energized, and this plunger is attracted by this direction. So this circuit is be open and the fault is isolations. Now we have to see in the basic schematic diagram of the this all the basic clipping circuit and what the auxiliary switch auxiliary relay outcome. If you are drawing this in sheet, so how can we draw the circuit diagram of the or schematic diagram of the basic clipping circuit? There is the schematic diagram of the basic clipping circuits of the plus point is the battery and minus point of the battery. Here the auxiliary relay and the auxiliary switch are there. So here you can see the auxiliary relay is connected to the parallel. There is the one auxiliary relay, arrow is auxiliary relay, and the relay main the relay contacts. So another protection main relay the contact from the large current conductions widely used to auxiliary relay cell in the sensor. So auxiliary relay is used for the any auxiliary protection. If you the main relay is not malfunctioning or the not able to operate from this fault, they will the auxiliary are in the action. And the second one is the auxiliary switch. Auxiliary switch is connected to the series with the coil of the circuit breaker. There is the one auxiliary switch. There is a connected with the series. If you are the any problem with related to open the circuit breaker or switch, then auxiliary switch will be the opens, and maybe there will be a manually turn on and turn off functions are there. So basic tripping circuit take the place to auxiliary switch is avoid the arcing and relay contacts. If you are arcing are there or relay contact are there, so both switches we have to operate together. So arcing condition will be reduced by using the auxiliary circuit due to a same operation, and the there will be a current will be limited by the two different switches. And the multi-contact auxiliary switch used for the alarm indication and interlock systems. There's the multi-contact auxiliary switch we will be used for the alarm indication. How can we use the alarm indication and interlock system? We will see in the next. Now we have to see the component of the power system. There will be, you can see the one of the wall power system diagram. There's the one of this is the generating unit. There is step up or step down, maybe a step down, step up transformer. This is the circuit breaker. This is the one bus bars and different lines are there. This is the transmission line. Another is this is primary substation. This is different. Another primary distributions and secondary transmissions. After they will be in the 66 kV, there's the 11 kV pole mounted transformer or underground transformer, and they will last to consumer. There will be the different zone of the power system. There is the generating unit, there is the sub station unit, there will be step up transformer. This is a transmission unit, and there will be a transmission substation unit, maybe where 220 kV or 66 kV. Or this is the also the transmission, distribution substation unit may be a 60 or most of there is a 66 kV, and there is a distribution line, and this distribution transformer is pole mounted or underground transformer. The 11 kV last of the consumer. There is a whole of the component of the power system. So when we see in the zone of the protection, which zone we have to see in previous transformer, there were very different zone in terms of the generating zone, transmission zone, and also used for the distribution of ETC. We have to see in the zone of the protection in next lecture, and how can zone is reflect to a protection of the different zone and different system. And after the we need to see the type of protection, what is the type of protections and how can they will be run. So this we have to end this lecture. Thank you for your attention. Thank you.